I will go over and review Quiz 2. Since there are several versions of Quiz 2, I'm going to specifically look at Quiz 2 version A. So some of the numbers on some of you guys' quizzes on this video will be a little different. So be sure that you don't get confused here. But I'm just going to do one version. All the problems have the same content, just different numbers. All right. And so this first problem, it says a company producing jigsaw puzzles has fixed costs of $4,000 and variable costs of $3 per puzzle. The company sells puzzles for $4 each. Part A, I want to find the formula for the cost function. Part B, revenue. And part C, profit. All right, remember your cost function for now, or at least in this chapter, is given in terms of your fixed cost plus your variable cost. All right, so your fixed cost is $4,000, so I know that it's going to automatically cost $4,000, plus it's going to cost $3 per puzzle, and so in these functions, Q represents the number of puzzles in this case, or the quantity of puzzles. So if I multiply 3 by the number of puzzles, I get 3Q, and that'll be our cost function. The formula for revenue, remember, revenue is the amount of money that the company brings in just from selling the product. All right, and so since the company sells the product or the puzzles for $4 each, then our revenue is going to be the price of $4 times however many we sell, which is a variable, and that's 4Q. Pi of Q is our profit function. Remember, we have this relationship or this equation here that profit equals the revenue of a situation minus the cost, right? And so I have my revenue as 4Q and my cost as 4,000 plus 3Q. Remember, we have to distribute the negative to both the 4,000 and the 3Q. And so when I simplify that, 4Q minus 3Q is just 1Q. So I'm just going to write Q. And then I have a minus 4,000. And that is going to be what I have for my profit function. And so part D says, for a quantity of 4,500 jigsaw puzzles, is the company making a profit? And basically I want to see here, I want to see if the profit is positive or is the profit negative, given that our quantity is 4,500. And so I'm going to plug in 4,500 into our profit function. That's Q, which is 4,500, minus 4,000. Which equals 500. So my profit is $500. Since that is greater than 0, that's positive, then I know that yes, the company is making a profit. Had this been negative, then I would have answered this as a no. Problem 2, it says determine if the following data represents a supply curve or a demand curve. And we have these values here. The way I went over this in class, we looked at, for instance, we try to answer this as price increases. For a demand curve, we would think about the consumers to fill in this blank. And for the supply curve, we think about the seller, right? So as my price increase, right? These are my prices here. 229, it goes up to 232, up to 237, up to 246, up and up, right? So as my price increases, my quantities also increase, all right? And so I can say that the sellers want to supply more products. Not only to supply, but also sell more products, right? And so this would be a supply curve. If I had the opposite type of thing going on, like our price was decreasing and these quantities were increasing, then that would be considered a demand curve. So the answer to number 2, if you had, again, version A is supply. Problem 3 is probably the most missed item on the quiz. All right, it says the number of passengers using a railway fell from 190,205 to 174,989 people during a 5-year period. Find an exponential function that models the number of passengers P as a function of the number of years T that have passed. Now, what I wanted you to do was use this formula here. Okay, number of people on a railway track a railway, number of passengers, that's not something that's necessarily organic, all right? And so we don't necessarily say that that's a continuous exponentially growing function, all right? That's why it's kind of in this section here. I did not take off if you use the other form of an exponential function and you did the work right. Okay, so if you did use that function, although we didn't want you to do that, I still gave you credit if you did it correctly. All right, but what we want to do is we want to find the exponential function that models this, and I'm going to use this function here. All right, well we're giving a couple of pieces of information. I know that my P naught here is the initial amount, which is 190,205. I also know when t equals 5, I know that P of t, that's like plugging in 5, is 174,989, right? And so this gives me P of t, that 174,989, P naught, that 190,205, and T is 5. That helps me find my growth factor. Or in this case, it's going to be a decay factor since it fell or decreased. So I'm going to put these values into my equation. A, I don't know, but T, I do know is 5. If I want to solve that, I want to divide both sides so that I can isolate the exponential function or the exponential expression. Those cancel, and I get A to the 5th equals this thing here. Now, I'm not going to round this right now. I'm just going to leave it as that fraction. If I want to solve for A, I've got to undo the raising that A to the 5th power. So I'm going to do the 5th root. And I get that A is approximately, and if I round that to 3 decimal places like the question asked, I get approximately 0.983. And so my function in general would be P of t equals 190,205 times 0.983 to the t, okay? Part B says, what is the annual percent decrease over the 5-year period? All right, my annual percent decrease, if I'm using this formula, is going to be coming from this equation right here, right? Because we always know that A equals 1 plus R, or it'll equal 1 minus R, depending on if we have growth or decay. We use the minus when we have decay, and so that's what we have here. Okay, and so I have that 0.983 equals 1 minus R. All you have to do is subtract 0.983 from 1, and then you're going to get that R equals 0.017. And so my annual percent decrease, if I write that as a percentage, is 1.7% approximately. Some of you may have gotten 1.6 or something similar. It depends on what you did in this step right here. I just left it. I didn't write this as an approximation. I kept it as the exact value, and then I put it in my calculator. All right, but that's a review of that quiz. And that's the end of this video. Actually, I do want to make note of one thing, and I'm sorry about this. In the last video, we looked at this type of example here. And we went through the process of solving by dividing, solving for t. Let's say I solve for r, for instance. I divide both sides by p. I get b over p equals e to the 3rt. I take the natural log of both sides. And of course, the natural log here will cancel that e, and I'll get 3rt. Divide both sides by 3t. And I'll get here that r equals the natural log of b over p all over 3t. All right, this, in my opinion, is a great acceptable answer. But Wiley Plus wants you to go a step further. When we went over logarithmic functions, we said that, well, when I do the ln of, let's say, I think in our notes we might have said a over b, and so I'm going to do that here. ln of a divided by b is exactly the same thing as ln of a minus the natural log of b. Okay. All right. And so this is what Wiley Plus is going to want you to do. Now, if this were a test, you stop right here, you'll be, that's perfect. That's almost perfect. That's perfect for me. But Wiley Plus is very particular, right? So I'm going to do the natural log of b minus the natural log of p all over 3t. Now, I'm not sure if Wiley Plus had you solve for r or t here, but you're going to get a similar solution depending on which variable they asked you to solve, and it should be written this way here. All right, sorry about any of the confusion. But that concludes this video. I hope it's helpful as you continue to study for your test.